Hello and welcome to another session of Sqoop. So what you see here on the screen is basically a simple import statement. So we have the retail TB under which we have a table called as orders, and we are importing this into a target directory. We are just using one mapper here. So let me go ahead and execute this. So we have 68,833 records which are executed or which are imported, and if you see here, right, there is no reduce job that has happened because basically there's just one phase where you just connect and import the data. There is no concept of shuffling. So this is one thing I want you to remember because this is something we're going to talk about in just a few minutes. Okay, so anyways, let me just go ahead and check this data. So we have this data in just one file because of one mapper. So I'm just going to do a simple cat command, and we have all this data. So let me take you to the MySQL database. So this is the table that we have imported. I have picked some records, 4 records. So what we want to do is, like in earlier classes, we have seen how we can incrementally import this data, right? So if a new record is present, then we can incrementally import this data. But what if in the existing data there are some changes? Say for this order ID, currently the status is on hold. What if it changes to complete? Similarly, if it is closed, if it is going to on hold, right? Now when you do an incremental append, you will not be able to get this data because it's not a new record, it's an existing record. So we want to get all those records which have changed. So this is basically something which we can achieve in Sqoop. Now this kind of scenario are very rare. To be very honest, I have not seen this kind of scenario, and it's most likely that you will not be seeing this kind of scenario because HDFS or Hadoop Big Data is not for transactional data, guys. So this is basically if you're using your normal relational database, this is kind of frequent occurrence, but you will not see this thing in the Hadoop system. But anyway, this is a feature that the Sqoop provides, and in rare scenarios you might see. But let's see how we can achieve this. So basically, what we are saying is we want to retrieve the data of records which has changed. Right now, for that, what we'll have to do is we have to identify the column using which we can say, hey, you know what, using this particular column I'm going to compare the data which is there in HDFS to the data which is there in your MySQL. So a primary key column, so let's say your order ID, right? So your order ID is here in the Hadoop, your order ID is there in the MySQL. So what will happen is the order ID in each of this Hadoop and your MySQL, they are compared, and using the as a primary key, it will go and check if the data is changed between the Hadoop, like the odd for this particular order ID. Let's say for this particular order, is there any change on the order date? Or for this particular order, is there a change in the customer ID or order sheet? If there is a change, which basically means that something has been modified, so that particular record, it will import it and it will update it. So this is how we can basically make sure that we have the latest data, or the data is synced between the Hadoop and the MySQL. So before that, what we will do is we will have to update some data because we have already imported this data. So we will update this data. So this is the data that we have. So let me go ahead and update this data. So I just updated each of this data. So basically on the order status, I am giving some test values based on the order ID. So if I go ahead and execute this and I check the data here, you should find the new values like test one. This is easy for us to identify this data. This is what we have updated. So let me go ahead and commit this data. Now we will go ahead and execute the Sqoop command. So let me clear this up. So this is the Sqoop command that we have to use. So this is basically something that we have already know. Username, then we are taking the password from a file, table name which should be order. So let me go ahead and change this. And this is the target directory, so I think this target directory should be orders. Okay, let me change this. And then incremental last modified, so basically we are saying this is an incremental, but instead of append we are using last modified. The check column is order date, so basically this will tell you like within this order id which is used as a comparison. So we mentioned this here, merge case based for comparison. So it is used for comparison, but it will not compare all the values, right? It will only compare the values which are basically changed after a particular date. So you give the order date here, so it says from 2014 0515, whatever the values that has been changed, I will only take only those values for comparison. So let's say let me take you back here. So I have these values. So these are the order date, right? So this order date, so we have 2014, we have March, then we have April, then we have 6, right? So what it does is it will take, you know what, anything which has changed from 2000, I mean 0415, I will only use those for comparison. So it, even though there is a change in this the first two records, but because it does not fall within the value, the order date which we mentioned, it will not use for comparison. So that's what it means by last value, right? So let me go ahead and execute it, and then once we see the data it will be a lot clear. Now if you see here, right, we also have the reduce phase. That is because the reduce phase, we want the data to be shuffled. The data gets shuffled because you have to do this comparison, right? So use a merge key to compare this data. That's where this reduce job is invoked, and it just gives you the last value which is updated. So it is just saying that, hey, why don't you create a Sqoop job, because you don't have to remember the last value here. So that's a good suggestion that, you know, your log is giving you. So anyways, let me go and check this data. So I have this data here. You can also see the naming change here. So let me just show you. So here it says part R. R is for reducer. If a reducer job is involved, then it will have this R. In earlier cases, we have seen this name as part under part hyphen M. Not that it is important, but just to check whether it's a reduce job is involved or just is a mapper job. So what I'll do is instead of checking one by one, I'll do a grep, and I'll just grep for those order IDs that we have, right? I'll use maybe, what was this order ID? Okay, I 6. Okay, I think I can I'll copy it from there. I don't remember exactly. Okay, so this was 1 2. All right, I'm just grepping these values. Okay, so you can see here, right? So these two values 68809 they did change, right? Even though on the SQL side we have changed this, but it didn't change. That is because the last value that we have given is basically greater than this. We have given 2014 0515. If you see our query, where was this last query? So our last value was 2014 05, so 2014 0415. So all the data beyond this is the last value, beyond this will be compared. So because this does not fall in that range, they are still not changed. But if you see here, this is 16 date 16 beyond 15, then this is 28 beyond 15. So these things have changed. So this is how the last value works. So once you have this last value executed, only those, it will basically compare only those data which falls beyond this last value, and then it will use a merge key that is used for comparison. It will compare, hey, for this order ID, did any of the columns change? If it changed, let's change it at the HDFS side. Let me just do a head here. Now this is the first record, it does not have any header. So how will Sqoop know that you have to check this particular column, this data with the date value, and this data with your status? Why cannot it be like, hey, it will just check the order ID with this particular column, right? How does it know? Because we have columns here, but we don't have columns here. So how it works is, it does not work with columns. Basically, it will check your columns position. So here the first position is order ID, so this value it will check with the first position here. Similarly, the second position is here, it will check the second position data here. That is how it is going to check. It is not going to check based on the column name, but based on the column position. The first column from MySQL is checked with the first column from HDFS. That is how the comparison happens. Okay. So your HDFS file and your MySQL database should have the same table name. It should have the same and it should have the same structure, and the column name should be in the same position. If your HDFS has the column names not in the same order as that of your MySQL, then there is an opportunity that it might fail, because you might go ahead comparing your string with your date or your date with your number, then the Sqoop will throw an error and it will fail. So make sure that the column structures, the table structure, the column positioning is all same between the HDFS and your MySQL database. Okay, so this is what we wanted to cover in this particular section. I hope this was helpful, and this is something that we will not use it that much, but anyway, this is an important feature, and it's good to know this, and I hope you were able to grasp this. It's a very simple concept, and I'll see you guys in my next class.